9. From the second section. How was that first section where you had to split up the two different equations? Okay, good. 7 and 9, number 7. Let's see. Trapezoidal sums. So I have x. I have f of x. 0. I think when y'all see one of these, you're going to go, oh my gosh. 0, 2, 4, 5, 6, 12, 9. I couldn't, for this one, I'm going to have to use the intervals that are given to me. It says to estimate from 0 to 6. So I don't have equal intervals here, so you have to be very careful with that, right? Do y'all see that? Because this 2, 2, 1, and 1, right? So I might have to even set up different. Before, remember, I did the width on the outside times, and then I added them all together on the inside. I might not be able to do that this time. But if you think about it, all right, 1 trapezoid, right? Trapezoid 2. Trapezoid 3. And 4, right? 1, 2, 3, 4. Right? Are y'all following me? All right, so trapezoid 1, this one, my height or my width across is going to be 2. And then here's base 1 and base 2. So 1/2 height, base 1 plus base 2. Trapezoid 2, which is this one. So now this is base 1, this is base 2. Again, my height is 2. So 1/2 height times. If all the widths were the same, yes. But I can't do it like that because if you look, once I get to the next trapezoid, this one, my height changes to 1. So you didn't even use it? So you didn't. I guess you could do that. A little less accurate, but you could do it. And then you could do that full equation. Let's see. Next one, 1/2. Whoa. 1/2 height times 13 plus 16 plus, and then the last one again, 1 times 16 plus 18. So Henry said he just left off this 5. So they were all equal widths and then did with the height over 2 times, and then the first endpoint, and then 2 times the next, 2 times the next, and that one. So either way is fine. I don't know what you get here when you plug that in. Uh, 21 plus 22 plus half of 29, half of 34. So what do you get? So 17 plus, what'd you say, 13.5? 21 and 22. 73.5. Oh, it's 14. Yes, yes, yes. Okay. 74.5. Did you? Oh, okay. So just a little off. Does that make sense how we use the table there? A lot easier if you have equal widths too. And then what'd you say, 9? Are they all equal? 10, 15, 20, 25, 30, 35, 40, 45, 50. Yeah, they're all equal. So that's nice. So it says use trapezoidal rule with n equals 10. Okay. So the table's set up nice for me. Rectangular swimming pool, 32. Blah, 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 1 minute. Okay. So it says volume is the integral from 0 to 50 of 30 times h of x dx. And the h of x is given to me in a table, right? So what I'm going to do is I'm going to do 30 times the integral from 0 to 50, h of x dx, and I'm going to use trapezoid rule to do this one. So I've got this 30 on the outside, we'll say approximately, and then I'm going to start, my height of each one, or the space in between, is what? 5. So 5 over 2, remember it's height divided by 2, and then times, and I'm going to take each of these endpoints, but the first and the last is only going to be once, every one in the middle is going to be twice, right? If you look back at this, you'll see how the 12's only in here one time, but the 9's repeated, the 13's repeated, the 16's repeated, but the 18's once. That's why. All right, so we're going to go 6 plus 2 times 8.2, and I'm just reading these straight off the table. 2 times 9.1, 2 times 9.9, 2 times 10.5, 2 times 11. Oh, I got to give you all the program. Okay, I think I gave the older calculators, and then I typed it in Khalil's so I could give to everybody. That last one, that 13, doesn't get doubled because remember those endpoints just stay as they are. And now it's just on your calculator. You plug all that in, I hope you get 15,900 because that's what they got. Oh, no. Did you say no? Oh. 15 times 5. These two are going to give you 75 times. I got 33,269. No, you didn't. Oh, no, I did times 5.2. Okay. Seven, 15,900. No. Yes, that's what I got. What are my units? Feet cubed, that's right. Cubic feet. Look at what I'm finding. I'm finding volume. My table is in feet, so volume would be cubic feet. Yes. Previous section. Oh, I like this one. All right. I got two different equations that I have to use here. I'm finding the area under, and I'm going to use integrals. And because it's two different functions, I can't just do the integral from 0 to 2. I'm going to have to split it up into these two. So I'm going to do from 0 to 1, and I'm going to use that equation because that'll give me this area. So x squared dx. To that, I'm going to add the integral from 1 to 2 of 2 minus x dx. And that should give me the total area of the shaded region there. So antiderivative of x squared is, yes? but I'm going to evaluate from 0 to 1. And antiderivative here, and that's just a polynomial, so 2x minus 1/2 x squared, evaluated from 1 to 2. Y'all good there? And then plug it in and subtract. So I'm going to do 1 minus the 0 plus, and then I'm going to plug in 2 and I'm going to subtract, plugging in the 1. Yes, since that is a linear function there, you sure could have. It didn't tell you what to use there. You can use a shape for sure. It's probably easier. 1/3 plus 4 minus 2 would be 2. 2 minus 1/2 would be 1.5. So 1/2, so plus 1/2. All right. So that would be 2/6 plus 3/6, which would be 5/6. You good? What else? What do you think about trapezoid rule? It's fine. It's aggy. It is a little aggy. Look at number 10. Well, I'll just draw it for you and show you, because this, I've seen this a couple times on prior tests where they use something like this. It's a pond. Yeah. That says feet. 520. I'm going to do it like this. 800. It's number 10 from last night's section. 1140. I meant to give it to y'all and then I forgot, so we'll just do it together. 1110. These should all be the same, but they're not. 860. Yeah, that's supposed to be the same space, sorry. All right, so it says that as the fish and game warden of your township, you are responsible for stocking the town pond with fish before fishing season. The average depth of the pond is 20 feet. Using a scaled map, you measure distances across the pond at 200 feet intervals, as shown in the diagram. Use the trapezoid rule to estimate the volume of the pond. What should I do? I see this is the average depth of the pond is 20 feet. But then it says distances across the pond at 200-foot intervals. So your width is 200, right? Each one of these I'm thinking is 200. Here's the way I see this. Trapezoid. Is that the way y'all see it? So if I'm doing this, I would say, okay, and actually I missed one here. But I would say this is 1, 2, 3, 4, 5, 6, 7, 8 different intervals. My width each time is 200 times, and then I'm just going to start 520, and then 2 800s, and then 2 thousands, and all the way down. Actually, I got, I think that this is going to be this, and my first one is 0, like that. Yeah. Yes, sorry. Sorry, yeah. Y'all in agreement with me? How do I what? I don't know, that's what I'm looking at. I think that that might be some, maybe so, since that's depth, since this would give me, yes, because this would give me area. So let's see what happens. 100 times, then I'm gonna do 2 520, so that'd be 1040, plus 1600, plus 2000, plus 2280, plus 2320, plus 2220, plus 1720, and then 0. Yeah, 200 divided by 2, because the width each time is 200. Right? So because it's trapezoid, that just gives me area. So that's surface area of the pond, essentially, is what that is. This is surface area. And I got 1318000. This would be square feet. Agreed? That's not what they asked me. They asked me to use the trapezoid rule to estimate the volume of the pond. So that's how much area is across the top of the pond. Well, if I want volume, then it's area times what? The depth or the height, right? Because volume is length times width times height. Area is length times width. So now I need to take this and times it by the depth of 20. And I get 26360 cubic feet this time. That is a lot. Nice pun. Does that make sense though, using that trap rule? It's just finding areas, all it's doing. All right, let's see what we're going to